welcome to the Geozeum, and what I'm going to do today is I'm going to talk about what you guys are supposed to learn in 4th grade, and about rocks. And I'm going to tell you from my perspective. I'm a geologist. My name's Phil Stouffer. You call me Fossil Phil because I like to study fossils. But I'm a geologist, and I worked for many years teaching and working for the government studying faults. And there's lots of faults in this region, and these are maps that show them. But faults go through rocks. We're going to focus on rocks today. And I've got a bunch of rock samples up here. I'm going to pass them around. You guys get to put your hands all over them and look at them, smell them, taste them if you want. But I wanted to emphasize that every rock has a story. Okay? Let me tell you a little bit more about what geologists do. Geologists are the people that study the earth. We study things like earthquakes and faults. We also study volcanoes. Monitor them, because sometimes volcanoes blow up and they can really cause a bad day when that happens for the people that live near it. We also study coastlines and oceans and how sea level changes and what the impacts of big tsunami waves like the ones that came in Japan, and then those huge coastal storms like the big hurricane that just hit the East Coast, Hurricane Sandy. Geologists are trying to help people live in safe places. That's mostly what geologists do nowadays. A lot of geologists also hunt for oil and gas, and they work in the oil and gas industry, and they work with coal, but they're also working in all kinds of alternative energy programs. For example, did you know that San Francisco gets almost 90% of its energy, not from oil or gas, but from hot rocks under the ground? Up north of San Francisco, there's a big volcano, and they have drilled holes down there, and that's where they get their heat to turn engines that power most of San Francisco. Isn't that cool? So anyway, I'm going back to talk about how rocks, every rock tells a story. And there's 3 kinds of rocks. Let me see if you've learned them. What is the kind that forms when molten hot material cools? Yeah. Igneous. All right. I can see you guys have learned this already. Okay, when rocks break down and then they turn into, what do they turn into?
Sediments.
Sediments. And then what happens to sediments when they turn to rock?
They become sedimentary.
Sedimentary. All right, now if you take an igneous rock or a sedimentary rock and you put it under a lot of heat and pressure.
Metamorphic rock.
Oh, you guys. Who's the teacher here? You guys have been more.
All the hands go up.
All right. You made my day easy. You know, I teach geology in college, and it's amazing how many college kids don't even know what you guys know already. It's wonderful. Don't forget it. You'll have to learn it again in college. All right, so I'm going to start with igneous rocks. And every rock has a story. And yeah, we can name a rock, right? We can say, what is this? This rock has a funny name. You think?
Granite?
Close. If it had pink crystals in it, I'd call it granite. But we actually, if it's black and white.
Garnet?
Close.
Marble?
Nope. I'm going to go ahead and tell you because this is a funny one. It's called gabbro. Gabbro. And this is the most famous rock around here. This is what there's a huge mine right over between San Juan Bautista and the town of Aromas over here on the way to Watsonville. There's a big mine where they take this rock out. What do they do with it? It's all broken up. They grind it up and they make, you see it along the railroad tracks and you see it, they make it, put it in building materials. So I'm going to pass around this piece of gabbro. Everybody see? What's that rock have in it that make it black and white? What are those little things? There's a simple name. Here's another rock. What are these things when you see in a rock? Nope. This is an igneous rock.
Is that mica?
Mica is a kind of rocky mineral you find in here. Oh, what did I say? They're minerals, but these are actual crystals. See the crystals in these rocks? Yes. Some of it is quartz, and there's another one, well, granite, but it's a mineral called feldspar. Feldspar. So I'm going to bounce down this rock too. And,
I was trying to keep my
at
hands
the end,
from
I'm
that. Hold on to
you
it.
guys. But that one you saw is the gabbro is crystalline. This one's crystalline too. All right. And then here's another rock. Look how black this is. Can you see the crystals in it? What do you think it's called?
Obsidian.
Nope.
Basalt.
Basalt. Wow. I'm impressed. It's a black rock. There's a lot of iron and magnesium that makes it heavy. So when you touch this rock, it's basalt. Okay? Everybody look at it because I'll quiz you in a little bit. All right, now somebody mentioned this one. This one looks like glass. Obsidian, yeah. And so this used to be molten. It was melted. It was probably, several thousand degrees or a couple thousand degrees when it was molten, but it turned to rock. It is obsidian, yes. So, you have a question.
Native Americans use it to make arrowheads.
Exactly. They make arrowheads out of it. That's fossil. It's old glass. All right. So here's another rock that got blown out of a volcano.
It's really light, isn't it?
Yes, it's light. What is it?
I just heard.
Who knows?
Pumice.
Pumice or pumice. Pumice. And what's interesting is look at all the bubbles in it. Okay. Every rock has a story. This one shows that there's lots of gas that comes out of a volcano. And did you know, everybody thinks that lava comes out of a volcano, but most volcanoes put out as much gas and water vapor as they do rocks. A lot of that gas that we breathe comes from rocks, came out of the earth through volcanoes. So I'll pass around the pumice. Isn't that fun? Okay, so we've shown you some igneous rocks, and igneous rocks again formed from, who knows?
Lava.
Lava? What is lava? It's magma that comes up onto the surface. So these rocks that keep them moving around, everybody needs to get. Now once you form a volcano or a mountain range, with faults moving up the ground slowly or volcanoes forming over time, it gets exposed to the wind and the rain. And wind and rain breaks down the rocks. And what happens to all that material? Well, over thousands and thousands or even millions of years, that sediment comes down the rivers and gets into the lakes and streams, and they come down and they usually end up in the ocean, and that's where they accumulate. So we're going to look at some what we call sedimentary rocks. And I'm going to hold up a first sedimentary rock here. What do you see in the sedimentary rock here? What do you see? Not this one. Pieces of rocks. What do you see? Little teeny rocks? Well, they're minerals. These are pebbles. Right? They're pebbles, but now they're all compacted together and form a rock. It used to be a river gravel, like you'd find out there in a stream bed. You pick it up. But after sitting there for a long time, it turned to rock. There's lots of red in this rock. You see the red? That's a mineral that cements the rock together. It's mostly iron. And so this is a fun rock. Anybody know the name of it? Conglomerate. Man, you guys are awesome. Here's a piece of conglomerate. Now, here's a fun sedimentary rock. And, wait a minute. I'll give you a clue. This stuff here is made from this rock. Plaster is what that is. What is this?
Is it talc? Shale?
Nope.
Limestone?
Nope. Starts with a G.
I don't know.
Nope.
Granite.
No.
I know what it is.
I know what it is.
Nope. It's gypsum. Oh. But I want to tell you, everybody can see these layers. You see the layers in here? Hey guys.
Guys.
Hello.
Girls, let's pass it.
I want to show you this one. Look at this carefully. See all these layers? There's a white layer, and then a thin black layer, and then there's a white layer. What's interesting is this was in the bottom of a seabed, and when it got really hot and windy, the water would evaporate, and what happens when seawater evaporates? Salts come out of the ocean, and gypsum is a kind of salt. And so it would form a layer in the summer, a white layer, but then the winter it would rain and plants would grow back in the water and the organic material would accumulate, make a thin layer of dark. So this rock here, you could count from one year to the next. There's probably about 40 layers. It took 40 years for this gypsum to be deposited. Why am I talking about this? Because if you go out to Texas, there's a mountain of this stuff. It's 5,000 feet thick. And each layer is there in the side of the mountain. You can count up. And it took millions and millions of years for that lake, that big seabed to dry up. It's just a neat story. So here's gypsum. All right. So, you see what's on this rock here?
Oh, I know that one.
What do you think?
Shale?
Close.
Sandstone.
It's sandstone. This used to be on a beach, and when I pass this around, I want you to rub your hands on it. You can feel which way the current moved. As the waves and the water moved over it, it made little ripple marks. So here's sandstone, and you can feel it. It feels like sand. And a lot of people find stuff like this around here, out in the riverbed. What do you see in this rock? What do you see? Fossils. And so, igneous, sedimentary, or metamorphic. Where do you find fossils? What kind of rock? Igneous, metamorphic, or sedimentary? You find them in.
Is it metamorphic?
Nope. Sedimentary. Fossils, you only find fossils in sediments. The fossils have to be buried in sediments. And this is from the top of the Santa Cruz Mountains, up around 3,000 feet. But those are marine fossils. That means that the mountains, the rocks that are now exposed at the mountaintops were once in the bottom of the ocean. And geologists can study these. We can tell how old the rocks, the fossils are. And then we can predict how long it took for the mountains to be raised up. So here's a fossiliferous. It's sandstone with fossils in it. All right. Here's a really bizarre rock. Guess what? It used to be alive.
Petrified wood.
Petrified wood. This is from Arizona. There's a place in Arizona where there's a whole region where it used to be a forest, and a volcano blew up and buried all the forest, and all the rocks got turned to stone. And it's called petrified wood. Okay, so
Oh my god.
we've looked at a bunch of rocks. Keep them moving around. And we got one more group of rocks to talk about. Yes, metamorphic rocks. Okay, so what's it take to make a metamorphic rock? What happens to when about 20 young students go out on the playing field and there's a ball and you jump on the ball? Well, what happens? All the kids pile up on top, right? Who's going to be squished the most?
The ball.
The ball at the bottom of the pile. Good point, I was going to say. You've all felt the force of pressure and squishing. Well, rocks change when they get under a lot of heat and pressure. In fact, all the rocks that you see here when you put them under heat and pressure, they'll change into a different kind of rock. But we're talking about heat and pressure that's way down in the earth, maybe even miles or tens of miles in some cases. I want to show you probably the most famous from this area. This is a metamorphic rock. It used to be mud on the sea bottom, but it's been squished and metamorphosed. You think you know what it is? I'll give you a clue. It's got a young lady's name. It starts with a J.
Jasper.
Jasper! Yes, this is probably the most famous rock that we have around here. We have lots of jasper, and it's beautiful red. You go out in the creek beds, you'll find jasper all around here. It used to be in the bottom of the ocean, but now it's up on land. All right, now, this is an interesting one. Anybody ever see this one before? It sparkles, it's white.
Marble.
Marble, yeah. They used to grind up and make marbles out of it. Yeah, but this is marble, and this comes from the top of the mountain peak over here, Fremont Peak. This used to be limestone in a seabed, but it got put down in the earth. It probably was as much as 10 or 15 miles down at one time, and then faults moved it up. It's up on top of the mountain peak now. So marble, this is what they make statues out of. All right. Now this is a really nice rock. I really like this one. Anybody know what this one is? Nope. It's really nice. I really like it. Gneiss. It's nice. That's the name of the rock. And it's really kind of a nice rock. But it used to be granite. But when you put granite under a lot of heat and pressures, all the crystals get squished. Instead of having random crystals, now they're all in layers. And when you look at this one, look at it closely, and you can see sparkles in it. And they're flaky little layers. Anybody know what the flaky mineral that you find in stuff like this?
Mica?
Mica, yes. There's lots of mica in this rock here. All right, you guys all have to take my college class. You're doing too good. This is probably my favorite rock in the world. And it's also the oldest rock that you can find around here. In fact, this one here, I would bet it's almost 1 to 2 billion years old. It's had an amazing journey. Nope, talc is a mineral. This is a kind of rock, and it forms, it's a metamorphic rock. It means it formed from something else that got under a lot of heat and pressure. What was it originally? Or what is it? Quartz. Quartz becomes, when you grind it up, becomes quartzite. It used to be sandstone, sand that turned to sandstone, then you put a lot more heat and pressure on it, and it becomes quartzite. But this quartzite, because quartz is one of the hardest and most common minerals, it turns into something that's really dense. And this is the hardest rock. In fact, you could probably sell these to the military because they're very hard. And this rock probably came out of the mountains somewhere in Canada 1 billion years ago and walked down river systems over time and got buried and then exposed again and then buried again and carried an amazing journey. When you look at this one, it's been smooth because it was rolling down a stream bed, but you can see where rocks have bounced off of it, little things we call percussion marks. It's like where you can see it's been hit by other rocks as it moved down the stream. And so, now I've gotten to the close of what we're going to do. I've got one more rock here. And I'm sure you all know what this is, because it's the state rock of California. See, look at everybody knows what it is. It also, it feels scaly, like a snake.
You know what it is?
Serpentinite, yes, it's the state rock. That's really interesting. It's a metamorphic rock. It used to be down deep inside the earth, but then it got transformed as it got carried up to the surface. And this is serpentinite. And, okay, so, I want everybody to keep those rocks moving around for a minute. And so you learn about rocks. And what's important about rocks? Well, everybody has rocks underneath them somewhere, right? Your house is on rocks. Your house is made out of materials that were taken out of the ground. So it's very important for you guys to have a just general good understanding about what rocks are, and that there's all different kinds. And they form in different ways in different places. And rocks are they forming today? Where would you find rocks forming today? Where? Everywhere, just about everywhere. Volcanoes, right? Where rivers go into the ocean, deep down, rocks are forming. So I'm going to go ahead and stop there, and then I'm going to ask you guys to take just a few minutes to look around. I want you to look in this case over here. This case is full of fossils, lots of fossil wood. There's things in there that don't live anymore. They went extinct millions of years ago. I'd like you to take a look at some of these maps. See if you can find where Saratoga is on one of these maps and see how close you are to the fault. And then if you have not been in here, go into the fluorescent mineral room, and you can also have a few more minutes out there in the rock shop, Top's Rock Shop. Thanks for coming today.
Thank you.